This is Mr. Peters on lesson 92 in Algebra 1, and we are going to be talking about this is uniform motion problems, and these are going to be uniform motion problems that have equal distances. And that's kind of the crucial part to remember here, is that our distances are equal. Distances are equal. And I will say that one of the easiest ways that I have found to go through these problems is to make one of these little rate times time equals distance boxes. And we're just going to fill it out with the information that we can and then solve for whatever we're looking for. Okay, so let's read through this problem. We've got Candid and Pangloss, strange names, walked to the site of the disaster in 9 hours, right? So they were someplace, they walked to a site, and it took them 9 hours to get there. The next morning, they jogged back, so they were at the site, and they jogged back to their starting point, and it took them 3 hours to do that. So we want to know distance. How far did they jog if they jogged 4 miles per hour faster than they walked? So we know that distance is equal to rate times time. So let's fill in what we know. Okay, so the time they spent jogging was 3 hours. And the time they spent walking was 9 hours, right? That's what was given to us here. We were told that it took them 9 hours to walk from wherever they were to the disaster, and then 3 hours to jog back. Okay, well, what other pieces of information do we know? Well, another piece of information that we know is that they jogged 4 miles per hour faster than they walked. So their rate while jogging is faster, 4 miles per hour faster than when they walked. So the rate of their jog, and let's write it like this, the rate of their jog and the rate at which they walked. All right, we know that they moved faster when jogging, so if we take their rate of walking and add 4 to it, we have the rate at which they jogged. All right, so we have some constant here. They walked, the rate at which they walked, and then their jogging rate is their walking rate plus 4. And I'm sorry that that's kind of hard to see, right? So we want to make sure that we have the same variable in both of those boxes. Well, we know rate times time equals distance. Okay, so if rate times time is equal to distance, and we know our rates and we know our times, then we can just rewrite these as rate times time. That was my dryer going off. Rate times time. And down here I've got my rate and my time that I'm multiplying together. Well, what do we do with those bits of information? We know distances are equal, so let's set them equal to each other. Let's take the distance, and I'm going to write this out like this. The distance in which they jogged, and set that equal to the distance that they walked. So I can take this as 3 times RW plus 4 is equal to 9 times RW. Let's use our distributive property. We get 3RW plus 12 is equal to 9RW. 12 equals, looks like 6RW. So the rate that they walked, 2 miles per hour. Now, that's not our answer, right? Because what we're looking for is the distance. How far did they jog if the rate is 2 miles per hour for walking? Well, we know the distance. It's right here. That's the distance that they jogged. So we can take that, and we could say, well, 3 times RW plus 4 is equal to the distance they jogged. What is RW? It's 2. So we get to say 3 times 2 plus 4 is equal to the distance that they jogged, or 3 times 6, which is 18. That is the distance that they jogged. Thing of beauty, guys. Thing of beauty. Well, let's do one more problem. And this is the practice problem on page 386. Practice B on page 386. So I'll give you just a second to open up your books. You can pause this video if you'd like to get there, because I'm not going to write it all out on here, and we're just going to go ahead and set up our box here for distance equaling rate times time. Right, distance equals rate times time. All right, so I'm just going to assume that you guys have your books out and are ready, and let's do this. On Monday, Voltaire drove to town at 60 miles per hour. On Monday, he drove to town at 60 miles per hour. On Tuesday, he drove to town at 40 miles per hour. So this is Monday, this is Tuesday. He drove to town at 40 miles per hour. If the total traveling time for both trips was 15 hours, how far was it to town? So again, we are looking for distance, and we've been given total time and speeds, right? So here I'm going to say, well, this one, let's let that be Monday. Let's let this be Tuesday. And what we know is that 15 is equal to the time from Monday plus the time from Tuesday, right? He spent a total of 15 hours, which is just ridiculous. A total of 15 hours driving over the course of 2 days. And we need to utilize this information to solve for one of our variables, right? So I'm just going to start plugging stuff in here. We've got, for Monday, we know that the rate is 60. For Tuesday, we know the rate is 40. We don't know the exact times, but I do know that, hey, you know what? Monday, let's just throw TM for Monday. The time spent driving on Monday. Well, if the time spent driving on Monday is that amount, how much time is left over out of 15 for the time that he spent driving on Tuesday, right? Well, we can solve for TM. Or sorry, we can solve for TT here, the time spent driving on Tuesday. That's equal to 15 minus the time spent driving on Monday. And that's what we're going to plug in for the time spent driving on Tuesday. We've got 15 minus TM, right? Because the time spent driving on Monday plus the time spent driving on Tuesday should add up to 15 hours. Now, what do you guys notice about these distances here? These distances that we drew and have been talking about. Well, if he drove from one place to town on Monday and then drove from that same place to town on Tuesday, we can state that these two distances are, in fact, equal. So let's go ahead and write that out. We know that the distance that he drove on Monday is equal to the distance he drove on Tuesday. Well, how do we find those distances? We know distance is equal to rate times time. So we're going to take 60 times TM and 40 times 15 minus TM. That's a minus sign there. 40 times 15 minus TM. And now let's just replace. Let's replace these with what they are equal to. Let's do a little substitution. We got 60 TM is equal to 40 times 15 minus TM. From here, we get to use our distributive property. And we now have 60 TM is equal to 40 times 15, which is 600, minus 40 TM. Let's get our variables all on the same side of the equation. So let's rewrite this as, well, we're going to be adding 40 TM to both sides. Those cancel from the right. We're left with 100 TM is equal to 600. And from here we can just conclude, well, the time spent driving on Monday was 6 hours. Now, what are we trying to answer here? It says, how far was it to town, right? Some of us might stop here and say, hey, I found an answer to one of the variables. I'm good, I'm going to stop. But no, we need to figure out how far was it to town. I want to find distance to town. Find distance to town. Well, I can use either one of these. I can use this distance or this distance because they're the same. Let's use 60 TM. All right, so we know the distance that he drove on Monday is equal to 60 TM. And if TM is 6, I've got 60 times 6, which is 360 miles. 360 miles. All right, if you guys have any question, you can message me on LMS or join me for one of my Zoom tutoring sessions. I look forward to seeing you guys. Stay safe, stay healthy, be wise.